In this video, we want to work out the area to the y-axis. So if you have a look back on the video previous to this, area to the x-axis, it explains where we get our formula from and how integration is to do with area. So this video is just specifically getting into examples about area to the y-axis. But the previous video goes into an awful lot more detail if you want to have a look back at that. So in a similar fashion to the previous video, the signed area between the curve x equals g of y and the y-axis for y values between c and d is given by the integral of x dy between the limits d and c is equal to the integral of g of y dy between the limits of d and c. So here's our x-axis, here's our y-axis, here's our curve, and this is the point C on our y-axis, and this is the point D on our y-axis. And if we were interested in the area between the curve and the y-axis between D and C, we're interested in this area. So this means that the area to the right of the y-axis is positive. So for example, this area here is to the right of the y-axis, so it's positive, while the area to the left of the y-axis is negative. So area to the left of the y-axis would be negative. Again, it is important to find where the curve crosses the y-axis. And to find where the curve crosses the y-axis, we let x equal 0. And likewise, if you're interested in where the curve crosses the x-axis, you'd let y equal 0. So the area between a curve and the y-axis. The definite integral, so the integral of x dy between the limits d and c, is equal to the integral of g of y dy between the limits d and c, gives the area between the curve x equals g of y and the y-axis for y values between c and d. If the area lies to the left of the y-axis, then this integral is negative. So area to the left of the y-axis is negative, area to the right of the y-axis is positive. Find the area bounded by the curve x equals y squared plus 1 and the y-axis, and the lines y equals 0 and y equals 1. So when we hear area mentioned, we want to think integrate. So here's the x-axis, here's the y-axis. This is our curve, x equals y squared plus 1. This is 0 on our x-axis, and this is 1 on our y-axis. So this is 0 on our x and y-axis because it's the origin. So this is the line y equals 0, and this is the line y equals 1. So we're interested in the area between the curve and the y-axis between these points. So this grey area here. If we put x equal to 0, we can see that the curve does not cross the y-axis. So if x is 0, we have 0 equals y squared plus 1. So we'd have minus 1 equals y squared. So y would be equal to the square root of minus 1, which is not real. So therefore, it does not cross the y-axis. And we can see in our graph, this is the y-axis, and the curve does not cross the y-axis. Indeed, it lies completely to the right as shown opposite. So the curve lies completely to the right of the y-axis. So therefore, the area between the curve and the y-axis will be positive. Thus, the area is equal to the integral of x dy between the limits 0 and 1, which is equal to the integral of y squared plus 1 dy between the limits 0 and 1. So we integrate y squared, we get a third y cubed. We integrate 1, we get y, because we're doing this with respect to y, not respect to x. And then we substitute in our limits. Our upper limit is 1. So we have a third times 1 cubed plus 1 minus a third times 0 cubed plus 0. So we have a third plus 1 minus 0, which is 4 over 3. So the area between our curve and our y-axis between y equals 1 and y equals 0, so this area here is 4 over 3.